and welcome to Command Online Academy. In today's lesson, we want to look at partial variation. In our previous lessons, we discussed direct variation, indirect variation, and joint variation. And we said that in direct variation, when one of the variables increases, the second one also increases, and when one of the variables decreases, the second one also decreases. That is for direct variation, and it is always two quantities or two variables involved. In indirect variation or inverse variation, in inverse variation, we said that when one of the quantities increases, the second one decreases. That is, when the first one is increasing, the second one will be reducing. And when the first one is reducing, the second one will be increasing. So they go opposite to each other. That is for inverse or indirect variation. And in inverse variation, just like in direct variation, it always involves just two quantities. Then in joint variation, we always have a combination of direct and indirect variations. We have a combination of direct and indirect combination variations, and it always involves two or more variables. That is, the first variable varies with two or more other variables. So the minimum variables we see is 3. Assuming the first one is this A, it will be varying directly as another quantity, let's call it X, and inversely as another quantity, let's call it Y. And we can also have more of it, but for O level, we normally have only two other variables attached to the first variable in joint variation. Now we want to look at partial variation. In partial variation, this one is a special form of variation in which we have dependent variable and independent variable. Now what I mean by dependent and independent variable is this. One of the quantities, not a variable, one of the quantities is constant. A quantity that is not changing is said to be constant, and that one is not a variable. Now what it means is that every variable is a quantity, but not all quantities are variable. So in partial variation, we have a quantity that is not varying. So whether this first one increases or decreases, it always remains the same. That is one of the quantities in partial variation. Then we have another one that changes when one of the quantities increases or decreases. So that is what we have in partial variation. So assuming we have A as the main variable in partial variation, this A will be equal to a constant. let's call the constant c, and it will now be varying again with another variable. Let's say the same a is varying with b. Now saying that a is equal to c or is equal to constant means that whether a increases or decreases, c remains the same. It is constant. It is not changing with a. Now let's look at an example or examples of partial variation so that you understand it better. Okay, so let's see this question. In this question, we have that x is partly constant. This is how you know a partial variation. They will always tell you that one of the quantities is partly constant, then and partly varies as y. Now, if x is equal to 2 when y is equal to 3, and x is equal to 4 when y is equal to 7, find x when y is equal to 5. X is partly constant. Now, in solving this, x saying that x is partly constant, for that one, that statement, we just say that x is equal to the constant. So we can call the constant anything. Let's call the constant a. So x is equal to a. Here we know that a is a constant. You can call it k, you can call it c, you can call it another thing. Now, and they also say that x is x partly varies as y. X partly varies as y. This is a direct variation. X partly varies as y. It is not stated otherwise. You always take it as a direct variation, or else it is stated otherwise. So here we just see that it partly varies as y. So we take it as a direct variation. So we say again, here x is equal to a, that is the first statement. And then in the second part of the compound statement there, we have that x partly varies as y. and we are taking it as a direct variation, varies as y. Now, if we're combining the two variations or the two quantities, we have that x is equal to a. Now for the second one, we have to clear the sign of proportionality, and for us to clear it, we have to introduce another constant. Remember, this a here is a constant, so we can now say that x is equal to a, now plus, let's use k to represent the second constant. So we say ky. Now you say where now what it means is that in partial variation, we always have two constants. The first constant is there without any variable attached to it. This a, there's nothing attached to it, there's no variable to it. It is standing on its own. Then the second constant has a variable, which we now when we combine the two, we have this. Now the next step is for us to now put the values given to us. The question now says that if x is equal to 2 when y is equal to 3 and x is equal to 4 when y is equal to 7. Okay. Now we go here. They say that from this equation, x is equal to a plus ky. So let's put the value for x when x is equal to 2 and y is equal to 3. So let's put it in this relationship. This is the relationship connecting the constant and the variable. So when we put it, we are going to have 2, which is x, is equal to a is constant, we don't know it, plus k times y is 3. K times 3. Now this is the same thing as saying k times 3 is equal to 3k. So you can still say a plus 3k. Now please note it, let me repeat here, that here when you want to combine this relationship, x is equal to a and x varies as y. If you want to introduce if you want to remove the sign of proportionality here and create a single relationship for these two things, you are going to separate this a and this one, this first one and second one, with a plus sign. That is a plus the relationship you have here. and that is this a. X is equal to a, then plus ky. This is very important. You have to separate with addition sign, with plus. Okay, so that is this. 2 is equal to a plus 3k. You know how we got it. Now, the second part of the same question says x is equal to 2 when y is equal to 3, and x is equal to 4 when y is equal to 7. So we still put another relationship there. So what it means is that we can call this one equation 1. Equation 1, then x is equal to 4 when y is equal to 7. That is k times 7. K times 7 is equal to 7. K times 7 is equal to 7k, sorry. So we can remove that and say 7k. Now that becomes equation 2. Equation II. Now we use elimination method to solve this. This becomes simultaneous equation. Simultaneous equation. In simultaneous equation, we have two equations and we have two unknowns, two things that we don't know and we want to get them. Like here, we don't know the value of a and we don't know the value of k. Anytime you see equation with two unknowns, for you to get the two unknowns, there must be a second equation. So solving two equations together is what we call simultaneous equation. There are two ways to solve simultaneous equation: substitution method and elimination method. In substitution method, you make one of the equations, you take one of the equations, make one of the unknowns the subject of the formula. You can take this equation 1 and make a the subject of the formula, which you have learned how to do. Then when we make it the subject of the formula, we put its value in the second equation and solve. Or we can use elimination method. In elimination method, we subtract the bigger one from the smaller one. But if you start with one of the equations, you must subtract from it for all the variables or for all the terms. You cannot say here 4 minus 2 and you come here, you say 3 minus 7. If you are minusing the first one from the second one, you must minus all the terms in it. And if you are minusing the second one from the first one, you must minus all the terms in it. Now let's use elimination to solve this one. We can draw a line and now say, since in this equation 2, we have 4 here, we have 7 here, so we can easily minus 2 from 4 and minus 3 from 7, and everything will be positive. So we can say we are now minusing equation 1 from equation 2. So we say 4 minus 2, it is equal to 2. So 2 is equal to A minus A is equal to 0, so we leave it. Now 7 minus 3 is equal to 4. So 2 is equal to 4k. This is 7k minus 3k, which is 4k. Now we can now call this equation 3. Can call this equation 3. Now from this equation 3, let's get the value of k. 2 is equal to 4k. Now what it means is that k is equal to 2 divided by 4. K is equal to 2 divided by 4. That is, taking this 4 here to the other side, it becomes division. If multiplication crosses an equality sign, it becomes division. So it becomes 2 over 4, which is equal to 1 over 2, which is equal to 1 over 2. Now we have gotten one of the constants. We have two constants, a and k. We have gotten the first one as 1 over 2. Now let's get the second constant, which is a. Now to get the second constant, we can pick any of these equations, equation 1 or equation 2. If we pick it, we have a and k in it. So we can put the value of k we have gotten and then look for a. So let's pick one. Equation 1 is smaller, so let's work with it. It will be less cumbersome. So we now say from equation 1, two is equal to a plus 3k in equation 1. 2 is equal to a plus 3k. That is equation 1. So we put the value of k, which we have gotten, which is 1 over 2. Now we have that 2 is equal to, we still don't know a, we are looking for it, plus 3 times k. Now the k is now half, that is 1 over 2. Now this is equal to 2 is equal to a plus 3 times half is equal to, anything on its own is the number over 1. So the 1 up times itself and the 1 down times itself. So it becomes 3 times 1 over 2 times 1, which is 3 over 2. Two is equal to a plus 3 over 2. Now, the LCM, here we have, it is the same thing as saying a over 1. So LCM between 2 and 1, we have 2 as the LCM. Now, we say 2 divided by 1, that will give us 2. And 2 times a will give us 2a. Then we come to this side, say 2 divided by 2, it will give us 1. And 1 times 3 will give us 3. So we are now going to have that 2 is equal to 2a plus 3 over 2. 2 is equal to 2a plus 3 over 2. Now we take the 2, which is division here, to the other side. If division is crossing an equality sign, it becomes multiplication. So we now say 2 times 2 2 times 2 is equal to 2a plus 3. Now that means that 4 is equal to 2a plus 3. And it means that 4 minus 3 is equal to 2a. That means that 1 or 2a is equal to 4 minus 3 is equal to 1. So a is equal to 1 over 2. So it actually means that k is equal to 1 over 2 and a is also 1 over 2. In this case, the two constants are equal. In some other cases, you solve them and the two constants will not be equal. So, but for here, we have our two constants being equal. Now, we have gotten the two constants. Now, the question they asked us is that we should find the value of x when y is equal to 5. We cannot get the value of x when y is equal to 5, or else we know the two constants a and k, and we have gotten two of them. So how can we use the two constants to get and the value of y, which is 5 now, to find the value of k? Now we come to this relationship between the variables. For you to solve to get any of the variables now, when you have gotten the constants, you come to the relationship connecting the variables, which is this one, that x is equal to a plus k. When we discussed partial joint variation, we said that for you to get the equation or the relationship connecting the variables, that you solve and get the constants and put the value of the constants, and that becomes the equation connecting the variables. So when we put the constants, what we are going to have is that x is equal to a is half plus k is half also times y. This is equal to half plus 1 over 2. Then they say that our y here is 5, that we should find x when y is equal to x is equal to 5. Find x when y is equal to 5. So times 5. This one is the equation connecting the variables because we have put the values of the constants we have gotten. So we now have this times 5. Now that will give us x is equal to 1 over 2 times 1 over 2 times by 5. This anything on its own is over 1. So up times up and down times down. So it becomes 5 times 1 over 2 times 1, which is 5 over 2. So 1, this is not times, this is plus, is equal to half plus half plus 5 over 2. That is this we did here. 1 times 5 and 2 times 1. Then the half here is there, which is now half plus 5 over 2. Now this becomes, the LCM is 2. LCM between 2 and 2 is 2. So we have x is equal to, we take the LCM, 2 over 2 divided by 2 is 1. 1 times 1 is 1. Then plus 2 divided by 2 on the other side is 1. And 1 times 5 is 5. So this becomes x is equal to 1 plus 5 is equal to 6. So we have 6 over 2. So it means that x is equal to 6 over 2 is equal to 3. So we now say that when y is equal to 5, x is equal to 3. This is our answer. So when y is equal to 5, like they asked us that when y is equal to, or that you should find x when y is equal to 5. So we've gotten it here, that when y is equal to 5, x is equal to 3. This is the answer. This is the answer. You may write this statement, you may leave it if you like. Once you have gotten your value of x, you have gotten your final answer. Now let's look at another example. In this variation, both indirect, and joint variation, they may not be telling you that x varies with y. They may put it as a word problem, something that is a real-time problem, and they put it in variation form. So, but the procedure of solving it remains the same. No matter how they twist the question, or no matter the form that they put the question, you should be able to identify the variables and then know which one is varying. And then you start solving your question. Like in this example we're going to see now. Okay, so let's look at the question. This question is a word problem. The wages of some laborers are partly constant and partly varies as the hectares of land cleared. When 16 hectares are cleared, the wages paid is 470 naira, and when 40 hectares cleared, the wages paid is 1070 naira. Find the hectares cleared for which 2,320 naira is paid. Now this is a partial variation because when you just come to the question, you see that the wages of some laborers paid are partly constant and partly varies. So this is how the statement of partial variation always goes: partly constant and partly varies with another thing. Now our responsibility is now to identify the variables. The first one is wage. That is the main variable, the main thing that is changing. The wage, we can call the wage W, and it is partly constant. The first constant, we can call it anything. You can call it A or any other thing we like. Then and partly varies as the hectares of land cleared. That is hectares. So we can call hectares H. So it means that the wages is partly constant. So W is equal to A, and W varies, partly constant and partly varies as H. So W varies directly in this case because it is not stated otherwise. So we take it as a direct variation. So W varies directly as H. So where H is equal to hectares and W is equal to wages paid. So we are now going to put it this way. W is equal to A, and also W is equal to, W varies directly as H. Now here we know that we are using W to represent wage and we are using H to represent hectares. So if we combine the two relationships here, we have that W is equal to, the first relationship and the second relationship are separated with plus addition. So we have W is equal to A plus. Now we can, to clear the second, this sign of proportionality here, we introduce another constant which you can call K. So is equal to KH. Now we have to define our abbreviations. So we can say where W is equal to wage, H equal to hectare, and A and K are equals to constants. A and K are constants. defining all the terms you use in your equation, it is very, very important. So you must, anytime you put an abbreviation, you must state what that abbreviation means. So having this relationship, we can now proceed to solve by putting the values of W given to us in the first instance and H given to us, and then to get equation 1, and then the W given to us in the second instance and H given to us in that second instance to get equation 2. Partial variation will always result to simultaneous equation. So for us to get our equations here, we go back to the example or the equation. They say that when 16 hectares are cleared, the wages paid is 470 naira. And when 40 hectares are cleared, the wages paid is 1070 naira. So we now say when wage is 470 naira, that is following this relationship, W equal to wage, A, we don't know A, plus K, we don't know K, and when wage is equal to 470, the hectare cleared is 16 hectares. So it's equal to K times 16. K times 16 is the same thing as 16K. Now we can call this equation 1. Then we also have that when the wage paid is 1070 naira, the hectare cleared is 40. So we go back. We now say for 1070 naira as wage, we still don't know our A, plus K, we still don't know it, that is K times 40. The hectare cleared is 40. K times 40 is the same thing as saying 40K. This is equation 2. Now we use our elimination method again. We can also use substitution method, but that is discussed in our lesson on simultaneous equation. Now using elimination method, which one is greater? The values or the terms in equation 2 are greater than the terms in equation 1. So let's subtract the terms in equation 1 from terms in equation 2. So 1070 minus 470, that will give us 600. 600 is equal to A minus A is equal to 0, so we leave it. Then 40 minus 16 will give us 24. So 40K minus 16K is equal to 24K. Let's call this equation 2, equation 3. Or we can also leave it. We may not put it as equation. Then from this equation 3, it means that if we have that 600 is equal to 24k, so if we make k the subject, so k is equal to 600 divided by 24. Six hundred divided by 24, that will give us 25. 600 divided by 24 will give us 25. So we have gotten one of the constants, k, as 25. So we have to get the second constant in order to use the relationship between the variables to solve anything. So let's get the second constant, which is a. To get the second constant, we can take any of the equations, equation 1 or equation 2. But let's choose the smaller one, the one that will be easier for us to solve. Let's choose equation 1, which is 470 is equal to a plus 16k. Then we put the value of k we have gotten, and then we look for a. Now we have that from equation 1, $470 is equal to a plus 16k, and we already know k as 25. So we have that 16 times by 25. So we have 16 times 25 is equal to 400. Now that means that a is equal to 470 minus 400. So a is equal to 70. So we have gotten our two constants, a and k. So we put it in this relationship to get our main equation connecting the variables. We put the value of a and we put the value of a. So we have that w is equal to 70 plus k is 25. So we have 25 times h, that is 25h. So this is the equation connecting the variables. Now, we can use this equation now to solve anything we want to solve. If it is h that is given to us, we can get w. And if it is w that is given to us, we can get h. Now, in this case, let's go to the equation. We are asked to find the hectares cleared for which 2,320 is paid. 2,320 is paid. Now that becomes from this, we already know the wage as 2,320. So we put everything here and look for h. Like this. So we solve this. Say 20 minus 70 minus 70 is equal to 25h. So with this, we have that 2,250 is equal to 25h. That is 2,320 minus 70. That will give us 2,250 is equal to 25h. And now we say that h is equal to 2,250 divided by 25. So whatever we get, it becomes the value of h when wage paid is, that is the hectare cultivated, when the wage paid is 2,320. So you can divide it and get the final value of hectares cultivated. So this is how to solve partial variation. Now let's look at our assignment. The resistance of a bus is partly constant and partly varies as the square partly varies as the speed full stop. The resistance of a bus is partly constant and partly varies as the speed. At a speed of 30 kilometer per hour, the resistance is 70 Newton. 70 Newton. Is 70 Newton. Then y at a speed of 40 kilometer per hour, the resistance is 140 Newton. Now the question is, what will be the speed? What will be the speed when the resistance when the resistance is 230 Newton, is 230 Newton. That is the question. So the resistance of a bus is partly constant and partly varies as the speed. At a speed of 30 km per hour, the resistance is 70 Newton, while at a speed of 40 km per hour, the resistance is 140 Newton. 140 Newton. Then what will be the speed when the resistance is 230 Newton? So you solve this and submit it. Thank you.